All right. This is awesome. Thank you for having me today. This is going to be so much fun. Thank you for that awesome introduction, Glenn. I really appreciate it. So, yeah, we're here to talk about, does your API need a REST? Check out GraphQL. My name is Dan Vega, Spring Developer Advocate at VMware. There'll be some code. We're going to go through a quick demo, but most of the code we're not going to write today. It's in a repository. You can go ahead and use this fancy QR code. I promise you, it's a legit QR code. I'm always worried about QR codes. Like, is this thing for real? I promise you, this will go to my GitHub repository, which you can find at github.com/Dan Vega. There is a repo in there called GraphQL Store. That's a lot of the kind of code that we're going to cover, but we're going to talk a lot about concepts and high level stuff and kind of what GraphQL is and why you might want to reach for it. If you don't know who I am, again, my name is Dan Vega. I'm a husband and a father to two little princesses right there. We live outside of Cleveland, Ohio. I've been doing this software development thing for like 23. I don't even want to admit it. It makes me feel really old these days, but I've been doing this a while. I think one of my favorite hats that I've worn is a Spring Developer Advocate hat, the one I'm currently wearing. I often joke that I have been a Spring Developer Advocate long before VMware was paying me to do so. I love creating content. I love learning new things and kind of helping teach that back to community. So if you want to learn more, you can check out my website, danvega.dev. You can check out the Tanzu Developer Center, really great resource where I have some content on there as well as my fellow coworkers. So check out the Tanzu Developer Center there. The Real Dan Vega on Twitter. If you are over there, we can join in the conversation there. And if I'm not doing this, I enjoy running in golf. So I want to tell you about another show we have on the Tanzu Developer Center called Spring Office Hours. We are actually have a session today at 3:30. If you want to learn more, you can head over to Tanzu's Developer Center and check out the show Spring Office Hours. This is really a place for Deshaun and I to help answer your questions, keep you up to date with what is happening in the Spring ecosystem because it is large. There's a lot of moving parts. There's a lot of things going on. And it's hard to keep up even for us who get to do this every single day, right? So we're kind of your resource for getting you caught up on what's going on in the Spring world, as well as answering your questions. So go ahead and check that show out. So what are we here to do today? We're going to talk about why GraphQL first. Like I don't like to be told just to use something. I need to understand why this thing is something I should be interested in. What problems are we going to solve with GraphQL? Then you get me interested. Now I want to hear more about it. Once we do that, we could talk about what is GraphQL. A quick introduction to what GraphQL is. And once we get into that, now we can start to get into the weeds. Okay, I know why I need it. I know what it is. How do I use it? And how do I use it in the context of Java and Spring? We'll go through a quick demo of the graphical user interface and kind of write some queries. But then we'll dive into a little bit more features, high-level stuff, like what, past the getting started stuff, what features does GraphQL really give me out of the box? So please feel free to go ahead and ask your questions in the chat. So why GraphQL? What problems are we trying to solve? So I'd like to start with like this fictitious company called Waffle Corp. It'll give us a really good foundation of why we might want to move to something like GraphQL. So Waffle Corp is this direct-to-consumer breakfast products. We also have some strategic partnerships. So we sell products through some different partners. Currently, this is an e-commerce service application. It's written as a monolithic application in Spring using Spring MVC. It has a bunch of REST APIs. It has a front end written in something like Vue or Next. Next or React, whatever front end component framework you're using, that's great. Ours is kind of written in this. So we have this front end talking to this REST API that's written in Spring MVC. Our management has come to us and said, hey, we need to open up all of those REST APIs that we are using internally to our partner microservices. So we need them to have access to it. We also are working on our iOS and Android applications. Forever, we've had these PWAs. We need these mobile applications up and running. And forward thinking, we're thinking about some of these IoT devices, right? Like imagine a toaster that you can just push a button and order some new waffles when you're out of them, or a smart fridge that you can push a button and say, I need more syrup, right? So these are some things we're thinking about, and we need to open up our application to be able to use these different services. So let's talk about what might be going on currently in our system. So we have a client application is going to make a call to our Spring Boot, Spring MVC application, has a bunch of REST APIs. It's talking to a database. It's going to return data in some format, in our case, JSON, right? So it's our typical flow. How do we break this REST API up currently? We have many unique URLs. These are our fine-grained resources. And this is really the key to flexibility and reusability. And so we break these up into resources, right? We might have something for products. So now anything related to product might have a particular API route. Then we have things like reviews and orders and customers. And this is just like a really basic example, right? We know that, especially in the systems you're building every single day, this gets much more complex, but we're going to start with this as the basis for our app. Then what we want to talk about now is, with this REST API, how are we going to go ahead and serve or manage the expectations that our management team has come to us with? How do we kind of handle that? Well, we are going to have these IoT devices talking to this, right? So normally on the client side, we don't have to think about things like bandwidth or screen real estate or all the other things that we kind of take for granted when we're working on like a normal large desktop, right? Well, now we have these IoT devices talking to this API. So now we have to start to think about this, like, oh, do we really need to return the 40 fields in that products call to display all of that information on the desktop? Probably not on the mobile side, right? Also, we have all of these different calls going to our REST APIs just to kind of gather all the data we need to show on one screen. We're making a lot of calls there. Is that something we really want to do? So we have to think about this when we're building out the mobile applications. Then we also have to think about our strategic partnerships. When they're calling into our APIs now have to go public, and we need to think about things like, should we be returning all of that data back to them? Maybe we are returning some kind of data that has sensitive information just because it's an internal API right now. We need to think about that as we start to open up these APIs, right? And then we need to start thinking about these IoT devices. So we have like things like a smart toaster and a smart fridge. A toaster doesn't need 40 fields returned to it, right? Like it probably needs like a Boolean or, one or two fields at the most. And so we're starting to think about those. So all these things that are going on in our current REST API, we're now starting to think about, is this still going to work as we need to kind of meet the requirements that we've been given by management? So what happens is when we move to something like GraphQL, now we can kind of flip the onus on the client, and we can have a single endpoint. And we could say, hey, whatever information you need, you can go ahead and request it. No longer do I have to kind of update all of our REST APIs based on client requirements, right? Before, I would have had to have like refactored a bunch of endpoints or written new endpoints for different requirements. Now I'm saying, hey, here's the API. You, whatever caller, whatever client you are, you can go ahead and craft the request that you want, and we will send you back that response and only that response. We won't send you all the extra data that you don't want. So another scenario that comes up here is, this happens in kind of the desktop world or even the mobile world. What about a scenario where we make a call to our REST API, we grab some data from the database and we return it to the client? And so we're building out this screen where we want to get some product information. So we make a GET request. We say, hey, give me all the product data for product number 123. This is great. We have the information we need. And then we start looking at our requirements. We go, oh, we probably need some related product information on this screen. So we make another GET request out to the API and say, give me all the related data, right? And then we're looking at it some more. And we go, oh, we probably need reviews for this product on this screen as well, right? So now what we've done is we've made 3 separate calls to our REST API to gather all of the data we need on this single screen. And so what we could do is we could replace that with a single call to our GraphQL API. We could say, here, we need the product information, any related products, and all of the reviews for that product. And now in one fell swoop, we have all the data. And I know what you're thinking, because I thought the same thing, which was, well, Dan, why don't you just write a new endpoint that aggregates all of that data together? And sure, you can, but now you're writing more code, and then more code becomes something that needs to be maintained. And I would say at that point, you're doing exactly what GraphQL is there to help us with. And what are those things? So why GraphQL? Why should we make the move to GraphQL? So first off, no more overfetching of data. Like, we get only the data we ask for. If we're on a mobile screen and a REST endpoint returns 40 or 50 fields, we don't need all of that data coming down to us. We may not have the bandwidth to support it. It may slow us down. So we don't need to, no more overfetching. Give me just the data that I need. No more multiple requests for multiple resources. In the example we just saw, we had to call 3 different APIs to get the data that we wanted, which includes a waterfall network request on all of that nested data. Also, each client needs to know the location of each service. So I need to call service 1 to get that data. I need to call another service to get that data. You could always put things like behind something like a gateway, and that's great. But in this scenario, if we have a single GraphQL API, that can fan out to different services to grab all of the data that it needs. I love that it has a strongly typed schema. We know exactly what is going on in there in the API, and that leads to some really nice developer tooling that we'll see today. So that's my why. So now that we know why, we understand the why, we can move forward and talk about what GraphQL is. So what is GraphQL? Well, it starts with graphs all the way down. With GraphQL, you model your business domain as a graph. The QL stands for query language, so now we have GraphQL here. So GraphQL really started at Facebook. It was in response to some of the things we've talked about already. The mobile devices were taking over the share of requests to their services, and they noticed that and said, well, oh man, we're like returning all of this data. They have all these overfetching of data, all these multiple requests to grab everything that we need, because they had all these different microservices, maybe similar to your organization. You have all these different services that kind of aggregate data that needs to get sent back to the client. So they kind of came up with GraphQL. It was open sourced by them in 2015 and now is governed by the GraphQL Foundation. So there's a whole bunch of companies behind kind of the open source GraphQL community. You can learn more about that at graphql.org/foundation, and they do a really good job with GraphQL. So I always like to show this too when I talk about what is GraphQL. I'm not going to read this whole thing to you, but the one thing I want to point out is that GraphQL isn't tied to any specific database or storage engine, because a lot of questions I get are, hey, how does GraphQL talk to my database? And I don't know about you, but I don't hear those types of questions when we talk about REST APIs. Really, a REST API is a way for the client to communicate with your application, right? Database access is something we delegate to something else. In this case, it could be a repository, it could be a service. We're delegating that responsibility to something else. And the same goes for GraphQL. GraphQL is a way for a client to communicate with our application. It's asking for a request. Hopefully it's getting a response. If it's asking for data from a database, then we're going to delegate that to something else. In this case, a repository or a service. So there are 2 sides to GraphQL. There's a client and a server. On the client side, we have this custom GraphQL query language. It's kind of like SQL. It's kind of like JSON, a little bit of a mix of the both. It's called a domain-specific language, or a DSL. And what I really love about this is we talked about client-crafted queries are based on their needs. I need X, Y, and Z. And guess what? That response is only going to return X, Y, and Z, not everything else. And I really love the developer tooling. We're going to see example of the graphical client that comes in your Spring Boot application when you fire one up with Spring for GraphQL. I like this tooling. It really gives you some nice features right out of the box without having to configure anything. So we'll take a look at that. So that's the client. Then on the server side, what do we care about as Spring developers? On the server side, there's a GraphQL schema that defines your API. This schema, there's a schema definition language that is used to describe the schema. and it's based on a very simple static type system. Not a whole lot to learn to get up and running to quickly write a schema. And what I really love about this is there is a specification somewhere. And I know specs, wow, I got to conform to a spec. Specs are good in this scenario because it means that when we write GraphQL schemas on the server for Java, if we get called into a project on the Go side or the .NET side, and there's an implementation of the specification over there, it's going to be pretty similar. So we should be able to kind of catch up on another language pretty quickly. So it's based on the specification. If you want to read more about the spec, you can head over to spec.graphql.org and go ahead and read through the spec. Now, I know you're not going to read through the entire specification, but if you start to dig through there, one of the first things you'll find out about is the type system. So we talked about this simple static type system. How does it work? So here we are defining what we're calling object types. These are kind of representing the objects in our system, right? So in an e-commerce system, we might have things like products and orders. And the way that you do that is you start with the type keyword and you say, here, this is my object type. In this case, it's product. And then on the left, you define the fields. So I have ID, title, and description are the fields in my API. On the right are the types. The type also has this exclamation point here. All this is saying is this is non-nullable. You don't ever have to worry about a situation where you're checking for null. This is always going to have a value. Then we can define the types. So there are some built-in scalar types, 5 to be exact. We'll look at what those are in a second, but you can always kind of extend the type system and get custom scalars. We'll see an example of that later. So then we can also reference other object types. So in this case, products is referencing the object type that we created above. This is one of those custom scalar types I was telling you about. Date, there's a way through GraphQL Java to bring in some custom scalar types and use those. Then we have things like enums and interfaces. Here are the built-in types. Not a lot, right? Int, float, string, boolean, and ID, which is representing some type of unique thing in our system. So not a lot. So this means that it's pretty easy to get up and running. I don't have to like think about what type I'm going to give something. It's going to stand out here. It's going to be pretty, we know what we're going to use, right? So now that we have our object types, we got to talk about the next thing, which is operation types. So most types in our schema will just be those objects, the products, the orders, the reviews, the customers. But there are 3 types that are very special within the schema. And those are our queries, mutations, and subscriptions. So a query is a way that we can read information from the API. So I want to get a single product. I want to get all of the products. A mutation is a way to change data in the API. So I want to delete a product. I want to update a product. I want to create a product. Those are mutations. Subscriptions are similar to a query where we're reading information, but this is something where we might open a connection and leave it open instead of closing it. So you can think like your traditional stock ticker. I want to leave that open so I can keep getting data about that. So those are operations. So we have object types, operation types. With those 2 things, you can do a lot in a GraphQL schema, right? So here we go. We have our query operation. We have our type product from before. The way that we define a query is we use the type keyword. We give it the query type. And then on the left, again, is just the fields. So the field here is saying this is called all products. And then on the right is the return type. Now the little brackets just say, hey, this is going to be a collection. It could have 0 or many. And then we can even say, hey, this is not going to return null. But in this case, I don't even think we need that exclamation point. We're just saying, hey, we're going to return 0 or more products. We can also take in arguments. So this argument on the left, again, is the field name, which is ID. On the right is the type. That type is an ID, and that exclamation point is saying, hey, you cannot pass me a null ID. If you want to pass me something, you better pass me an ID. So the arguments is where it gets really interesting, because that's where we really get to start to piece together all of those graphs. So we also have things like enumeration types. Java developers, we should be pretty familiar with enums. This is a special kind of scalar that is restricted to a particular set of values. So in our case, on the left, we have an object type called order. We have a field called status, which is of type order status. That just means if you're going to define an order status, it must be one of the following: canceled, pending, ordered, shipped, or delivered. So those are enums. We also have interfaces. We, as again, Java developers should be a little familiar with interfaces. We have a review. This review has a title, body, and a rating. We may want to create a new type called a product review that implements review. So it is, if it implements review, it needs to have those three fields here: title, body, and rating. We can see that we're adding something like product that is special to a product review. And then the same with order review. Must have those fields if we implement review. We can also have arguments. So we start building out the graph. This is where it gets really interesting, right? We have arguments to it. We can each have, for every single query, we could take in some arguments that could return something, and then we can have arguments there. And this is where we really start to piece together this graph. You could see that the exclamation points in here say, hey, this is required. If you're going to call this, I need you to pass me a value. And so in a system like REST, you can only pass a single set of arguments, right? You can have things like query parameters and URL segments in your request. But in GraphQL, every field and nested object can get its own set of arguments, making GraphQL a complete replacement for making multiple API fetches. And this is where it gets really fun. So I have this query here. I'm going to say find customer by ID. It takes in an ID. We can see that we have a customer down there that has a field called orders, which takes in another argument called first, which is, hey, I just want to get how many orders from this particular customer. And then order has a bunch of fields on there as well. So now I can start to construct a query that says, hey, find me this particular customer. And for orders, just give me the first 5. And here are the fields that I want from both product and orders, right? Or from customer and orders. And an order brings back a product. I don't want all the product information. Maybe I just want a title. Again, arguments really allow us to start to stitch together this graph and the ability to get exactly the data that we want in a particular query. Variables. When we have arguments to a field, that must be dynamic. So the one we saw before, we hard-coded some values in there. We said, hey, I want the ID of 99 and the first 5. What if we wanted those to be dynamic? We could say, hey, give this a dynamic variable name. So you can construct that using the $sign. And then the customer ID is the name of that variable. On the right is the type. And then we go ahead and pass that in. So this tool that you're looking at here is what we'll see in a demo today. It's called GraphQL. And there's a way to write our queries out. And then in the bottom there's a section for variables and headers. So variables, I can set customer ID to an actual value, and that's what gets passed into our query. And again, we can also do things like headers. We'll see an example of maybe passing in like a security token, maybe an auth token. You can pass that through a header, etc. So those are variables. There's input types. And this is a way to kind of group a set of arguments together. So I talked about mutations as a special operation type before. Imagine a scenario where you want to create a new product. It takes in a title of which is a string, and it takes in a description and returns a product. This is great, but what happens when you really start to grow the number of arguments, right? So you might think, well, instead of taking in every single argument, I'm just going to take in a product because I already have an object type called a product. This is where that assumption would be wrong, because object types are meant for output. They're not meant for input. They can't be used for input. You can't do what I'm doing here and just accept a product into our mutation. But what you can do is create a special type called an input type. So if we create an input type called product input that has a title and a description, now I can take that as an argument into my create product field there. So those are a little bit of why, a little bit of what. How do we get started with GraphQL in Spring? So GraphQL in Spring is really thanks to 2 projects. One, GraphQL Java, The other is Spring for GraphQL. And I want to quickly talk about what each of them bring to the table. So we talked about Facebook open sourcing GraphQL. They did that back in 2015. And right after it was open source, GraphQL Java was started by Andy Mark, a software architect over at Atlassian. There's a really good episode of the Beautiful Podcast with my coworker and friend Josh Long with Andy Mark. They go into kind of the history behind GraphQL, why he started this project. If you're at all interested in that, I would definitely suggest taking a look at that. So GraphQL Java is this execution engine. There is no transport layer. There is no HTTP, no IO, no high-level abstractions. It knows how to execute those queries, and that's what it does, and it does it well. Very active on GitHub. It adds all of these custom scalar types that we might need. If you're interested in learning more about it, graphqljava.com. There's also a book out that Andy helped write with Donna Zhu. I hope I said that right, Donna. They have a book on GraphQL with Java and Spring. Go ahead and check this out. I've gone through some of this book, really good book on getting up to date with GraphQL with Java and Spring. So what do you mean by an execution, Dan? What does that mean? So it means when we write these queries and we send it over to the server, that GraphQL Java is the engine that parses this and knows what the data fetchers or data resolvers, you hear them referred to as different things in different language implementations. In our case, we have data fetchers here, and it knows that when you ask for a customer, I know how to go out and execute that. I know how to get a customer, or I know how to get a product. So it will parse that query and turn that into a bunch of data fetchers. So what is Spring for GraphQL? This was really a great joint collaboration between both teams, between Spring and the GraphQL Java team. Again, Spring is going to give its programming model. It's going to bring in a programming model that is familiar, consistent to Spring developers, and it's going to give us a few things, one of which is a Spring Boot starter. We'll look at what that means in a second. But two, talk about requirements. Like, what do I need to get started with this? There are some different versions based on different versions of Spring Boot and GraphQL Java. You can see that the current line is 1.2.x. That was May of 2023. That is built on Spring Boot 3.1, JDK 17, and the newest version of GraphQL Java, which is 20. So that's where we are with those. Again, if you need a requirement for a different version, we have those as well. So we saw that we could take the execution of the query and turn it into these data fetchers. But how does that happen now with Spring? So Spring is adding that transport layer. Now we have something to send the query over the wire, right? We can do this via HTTP. We can do it via WebSocket, RSocket. Now we have something to do that. So we kind of Spring takes the request, sends it over to GraphQL Java. And how does this work as far as like data fetchers goes? Well, it happens because we have at controller annotation. So our at controller says, hey, go ahead and look in this file for something that can be resolved as a data fetcher. And what is a data fetcher? It's just matching a method up to some field that we've defined in our schema. And so we'll see an example of this. But again, now we can take that query, send it over the wire, have GraphQL Java parse it, match it up to a data fetcher, execute it, and now Spring will return the response via HTTP, WebSocket, or RSocket. So how do we create our first GraphQL API? Head over to start.spring.io. Of course, we can fill in our metadata about our project. The first thing we need to do is pick our transport layer. So we talked about those different options. Here, I'm just building out a web Spring MVC application. So I'm going to pick Spring Web. I'm going to choose Spring for GraphQL. And then in this case, I got to talk to a database. And so again, what we're delegating the responsibilities of data retrieval to something else. I'm using Spring Data. I can use Spring Data JPA, Spring Data JDBC. I can have an H2 database, a Postgres database, whatever that matters. Like that is not going to matter for Spring for GraphQL, right? So we fill in all this information about our application. What do we get out of the box? We get this Spring Boot Starter GraphQL. And what does it have? It has dependency management, auto configuration, so you don't have to manually configure things. Has a bunch of properties that you can configure. We'll see some of those are for the development tools, but you could set things like observability and cores and all the things that you might need to when it comes to kind of setting up GraphQL. You get metrics out of the box. We'll see an example of that later in a slide. And then you get these graphical UI and schema pages, and testing support. Like everything else in Spring is not an opt-in. We are telling you here is the bits that you need to start testing your application. So we start with creating a schema. Let's say in our application, we had a product entity, and this product entity had ID, title, and description. So this is how our existing application is before GraphQL. Now we need to create a schema. So it starts with a schema file. So in source main resources, GraphQL, you can create a new file. In this case, it just needs to end in GraphQLs. You can call it whatever you want. I called mine schema.graphqls. And we're going to define a couple of things. The object type, which in this case is product. It is matching up one-to-one here. We could see that because we only have 3 fields. But the reason we start with a schema first approach here is because that product entity could have 50 fields in it for all we know. Maybe we don't want to make all of those available in the API. If there are 50 on the left and we only wanted to define 3 to 5 in our API, then we only define those in the API. So that's why our schema first approach there. Then we define a query that says all products is going to return a collection of products. So how does this work on the Spring side? So we create a controller. I'm going to call this the product controller. It has a repository. We talk to a database to get this information. I'm going to create a method called findAll that just returns what the repository returns from the database. The way that we tie this method to the method that we defined in our schema is using that @schema mapping annotation. So this says, hey, I have a mapping for you to the schema. The type name is query, because remember, it could be a query, a mutation, or a subscription. The field is called all products. This is great. This works. A little bit verbose if you just want to kind of tie the two together. There is a way to shorten this, though. We could just say @query mapping. This is kind of derived annotation of schema mapping. What this does is it says, I'm going to assume the type is a query. And if you name the method the same as you did as the field in your schema, then I don't need to know the field name. So now I can just use @query mapping annotation, and it will tie the two together. So when somebody requests all products, it is going to go ahead and talk to that particular method. There's also a really nice schema inspection report. I've done a video on this if you're interested in that. I'm gonna I'm gonna jump through some of these really quick because I wanna get to a demo and then take a look at some other features. We do support things like validation. So if you wanna validate an argument that's coming in, you can do so. And then there's a way to register new data fetchers. So I just want to skip over that a little bit and then get to the mutation mapping here. So we have a mutation mapping. We have a way to basically modify data. So I'm taking in 2 arguments here called title and description, and I want to create a new product. How do I do that on the Spring side? Well, I just create a new method called create product. It's going to take in a couple of arguments, and the way that we map those is by using the @argument annotation. That's going to bind that to the GraphQL argument. We have our @mutation mapping annotation. So now we're going to take in those arguments, title and description, and now we just pass those on to our repository to save those out. Simple as that. Now, mutation mappings. Remember those input types I talked to you about earlier. We could take in an input type as well. Well, how do we do that on the Spring side? Nothing further. I'm just going to create a new product input record, in this case, on my side that has those same fields. And I'll take that in as an argument, and then I can pass that off to my repository. What does this look like on the client side? Hey, if I go ahead and pass this in, I'm going to say, hey, create a new product. And what I want you to return is the ID, title, and description. It will go off and it will return the created product, which has the new ID, the title, and the description. Also, you could take in arguments. So the @arguments will allow you to bind the full arguments map onto a single object. How did I know about all these different arguments are flexible signature that we have here in GraphQL? This is from the documentation. So if you go in the documentation and look at the schema mapping handler methods, you can see that they can take any one of these arguments. This is how you can get some different information in here. All right, so with that, I want to do a quick demo of the graphical user interface. And I have an application running. I'm just going to show you that it's running. We're not going to walk through it, but I have this schema file. It's a little bit more built out than the one we just talked about, but it has things like product orders, customers, etc. And in my application.properties, I have enabled the graphical user interface. If I don't, it's disabled by default because you may not want to go to production with this where anybody could just type in some queries. Now with this and my application running, I can go to this new UI here. And this is right out of the box. This is a tool that we get that we can now start to, I hate using the word test because I'm not testing my queries, but maybe I can start to explore the API and start to test, how can I write out some of these queries? So we're here in the graphical user interface, and this is where I can write queries, but what if I don't know anything about this API? How am I gonna write some queries? We've all probably been in an organization where we've been asked to interface with some REST API, and then you go, hey, excuse me, how's that work? I don't know how that works. And so you have to get on the phone with some other team and ask them how it works. Hopefully there's some little documentation somewhere that tells you how it works, but that's usually not the case, right? Here with GraphQL, because it's a strongly typed schema, we have some introspection tools that allow us to take a look at that schema and generate some documentation. So here on the left, I have these docs that says, hey, here's what you can expect in here. So I go in here and I look at this query and I say, oh, queries. I know what those are because there's queries, mutations, and subscriptions. Here are all the queries that are available to me. Oh, I could see there's an all products. All products is going to return a collection of products. And a product has an ID, title, and a description. So without knowing anything about this API, I feel like I can construct a query to get some data out of this API. So the way I'm going to do that is I'm going to type query, and now I'm going to figure out, okay, which query am I going to run? As I start typing, you see that I get some IntelliSense. So again, because of the schema that's in place, it knows all these things, right? It knows which queries you're trying to find. So, oh yeah, I'm looking for all products. I'm going to go ahead and select that. So now from all products, there is no select star for products. Don't give me everything. You have to be very explicit about what you want back. So I want ID, title. Oh, and as you can see, as I start typing field names too, of course, I'm getting some IntelliSense on that. So I'm going to say ID, title, and description. And now I have a query that I can execute. So I'm going to go ahead and run this query. I'm going to say execute, and boom, it goes off to Spring, knows how to map that all products query to the controller. The controller is delegating to a repository to select this information from a database. It returns it back to me. Now, what if I didn't want all of this information? What if I just want the title and the description? Great. Ask for just that and get that back. Same thing with description. Maybe I don't want that. Great. Just ask for that and get that back. So that's an example of kind of all products. What about how do I get a single product? Well, if we go back to our documentation here, we can see there's a query called get product. The get product takes in an argument. Oh, that's helpful. So now I can go get product. And what if I wanted to pass in no argument? Will that let me do that? No, it is saying argument is definitely something you need to pass in. So I'm going to say, we know that this classic waffle has an ID of 1. I'm going to say that. And then again, you are getting a product back, so you need to be specific about what you are getting back. I'll say ID, title, and description, and then I can go ahead and run this. So I love the graphical interface, the graphical UI here, because it's a way to explore writing these queries. If you're new to GraphQL and you've never written one of these queries, again, it may look a little funny at first because it's kind of SQL, kind of JSON, it's its own DSL. This is a great place to start in your application to getting familiar with writing GraphQL queries. So with that, I'll go back to the slides and we can talk about some of the features here. I have about 5 minutes to run through some features here. So the first thing I want to talk about is observability. We saw a presentation earlier from Tommy and Jonathan about observability, the big push for observability in Spring Boot 3.0, Spring Framework 6. was not just in the core framework, it was in all of the projects in the ecosystem. And GraphQL is no exception there. So, what is observability? It's a way that we can basically get some visibility into what's happening in our application. We can't just throw our app out there and do one of these and hope everything's okay. We need to know what's going on. And I would say GraphQL lends itself to observability because it is one of those systems where I could hit an API and it could talk to 3 different sources for data, right? It could talk to a database and then maybe 2 other APIs to kind of aggregate all of that data together. So there's a way to go through, build this out. You can get tools like Zipkin to enable and expose those span and trace IDs. When I go in and I run a query here, I'm saying, hey, all customers, give me all the orders for that particular customer. And now if I had some issues with that, I need something in place to tell me what's going on there, right? So now with observability in place, I haven't done anything extra, by the way. This is just metrics that are being collected for me automatically underneath the hood. Now I can go into a tool like Zipkin and say, let me take a look at that request. So I hit that request. I get the details for that request. I can see line by line what's going on. Hey, there was a post to GraphQL. Here's the query. Oh, here's the fan out for all customers. Here's the field for orders of those customers. So now if you start to have issues there, you can start to really see what's going on. And again, distributed tracing is now kind of built in. It's not something that you have to bring in extra. Pagination. Pagination support was basically added using the cursor connection specification. And this was just added in 1.2. You could kind of roll your own before this, but the problem with rolling your own is you can roll your own, and then the team to the right of you can roll their own, and then they can roll their own. And you don't have this kind of consistent feel across your organization now. So I like specifications for this because we know we're all kind of doing the same thing. This uses the cursor connection specification. It's a way to navigate large result sets. The way that this works is it uses something called connections. We'll see this word come up. Basically, we saw the schema. We built out our schema with our object type, our operation type. There's a new type in there called a connection type, but don't worry. This is not something you have to write, and that is because Spring is basically going to add this connection type for us in the background. So if we have something that we need a connection on, we're going to have a connection type, and we can go ahead and take advantage of it. So here I have a schema where I have customers. Normally, I just have a field called orders where I get all of the orders. But what if I had, 1,000 orders for a customer? Maybe I don't want to display all of them. I have another field called paginated orders. And you'll see on the right there that returns a new type called the order connection. I have not created that order connection type. There's no declaration of that in my schema anywhere. Again, Spring is creating that for us. So now we have a way to say, hey, give me the first 10 records. Now I can start to paginate through this. There's an example in the repo of using some of the new features in Spring Data 2023 that allow us to kind of do this. And then I could pass in like a limit to my order repository. And now what I could say is, hey, paginated orders, give me the first 3. I just want 3 orders. And now our result just contains those 3. Again, you could have done this before on your own. Now there's a specification. If you've worked with GraphQL in other languages, I actually did this a few years ago and when I didn't even know what it was. I didn't know that there was such a thing as the cursor connection specification. And I remember writing these queries, and now I see them here in Spring, and I'm like, oh, okay, now this makes a lot of sense, right? So pagination in GraphQL 1.2. Security. Securing your GraphQL APIs is important. Also a little bit different, right? When we're used to writing security in REST APIs, we're kind of used to locking down resources like, hey, only admins can touch products. Maybe everybody can read reviews, right? It's a little bit different in the GraphQL world because we have a single endpoint /post or a post request to /GraphQL. So how do we do that? Well, we set up our configuration as normal. We go in and we can start to use annotations like, hey, make sure the person trying to access this particular method has a role of admin. So this is at a controller level. If we go in and we try to send a request without any authentication, we're going to get an error back saying, hey, this is forbidden. You can't actually do this. If you want to send in an authorization header in the graphical user interface there, We're sending in that authorization header. Now it goes through okay. This also propagates down to the different transport layers. So if you did this in like a service, it would work there as well. And another example of this is maybe I don't want all the orders in the system. Maybe I want just the orders for the person that is logged in. We can do that as well. Finally, testing, again, is not something that you need to opt into. We are going to get this right out of the box. I'm going to kind of fly through this really quick, but writing these tests, even if you've never written one, should look pretty familiar. Here's a query. Go ahead and test it. When I get something back, I hope I get all the products back. And in this case, I hope it has a size of 4. So yeah, there's some really great testing support out of the box. You can test independent of the transport layer. So you don't need to test over HTTP or WebSocket. You can just test your GraphQL queries, but you can also test over HTTP if you want to write more of an integration test. Then you can do a full integration test here. Some other features that we didn't talk about: batch loading. How do we solve for the N+1 problem? Error handling. There's a GraphQL client, so if you need to talk to other GraphQL APIs, you can. It supports GraalVM native images, data integration, and more. So with that, that's my time, folks. Thank you so much for sticking around. You can follow me on Twitter at @TheRealDanVega, dvega@VMware.com, and learn more at danvega.dev.